So we're going to review topics from sections 1 through 3 for your Module 5 quiz. So number 1, we want to know what the 6 trig ratios are for our angle theta. So our angle theta is right here. So if we label our sides, the side of length 6 is our opposite side, the side of length 3 is our adjacent side, and then our unknown side is the hypotenuse. So before we can write any of our trig ratios, we have to solve for the length of the hypotenuse. We have to use the Pythagorean Theorem. So we know 3 squared plus 6 squared is going to equal c squared. So we get 9 plus 36 equals c squared. 9 plus 36 is 45, so we get 45 equals c squared. Take the square root of both sides, and c equals, and when I simplify the square root of 45, which is 9 times 5, and 9 is 3 and 3, we get 3 square root 5. So go ahead and label that missing side, 3 square root 5. So now we can list all 6 trig ratios. So if we start with sine of theta, which is opposite over hypotenuse, we get 6 over 3 square root 5. If we simplify 6 divided by 3, which is 2, we get 2 over square root 5, and rationalizing the denominator gives us 2 square root 5 over 5. Now cosine of theta, which is adjacent over hypotenuse, is 3 over 3 square root 5. 3 over 3 is 1, so we're left with 1 over square root 5, which when rationalized becomes square root 5 over 5. Next we move on to tangent, which is opposite over adjacent, which is 6 over 3, which is just 2. Now for our reciprocal trig functions. We start with the reciprocal of cosine, which is cosecant. And remember, when we do the reciprocal function, we always take the non-rationalized version. So we're actually going to do the reciprocal of 2 over square root 5, which is square root 5 over 2. Next, we do secant of theta, which is the reciprocal of cosine, which is just going to give square root 5. And then cotangent of theta, the reciprocal of tangent, is going to be 1/2. Number 2, we want to find the lengths of the missing sides and angle measure. So it's based on this picture, it's going to be easiest to find our missing angle measure first. So we know the angles in a triangle sum to 180. So I know 180 equals 52 plus 90 plus the measure of angle A. So that gives me 180 equals, and then 52 plus 90 is 142 plus angle A. Subtracting 142, and angle A equals 38 degrees. Right. So now we want to find the missing sides. So that involves setting up a trig ratio using the angle we're given. So we're going to use theta as the 52 degree angle. So side AB, the side with length 12, is our opposite side. Length BC is our adjacent side, and then length AC is our hypotenuse. So we're going to set up trig ratios to solve for one of our sides, and then we can use the Pythagorean Theorem to find the other one. So I'm going to go ahead and set up tangent to solve for side BC. So I know tangent of my angle 52 has to equal my opposite side 12 over my adjacent side, which we're solving for BC. Now to solve for BC, the first thing we're going to do is multiply both sides by BC to get it out of the denominator of our fraction. So we have BC times the tangent of 52 equals 12. Now to get BC by itself, we divide by tangent of 52. And BC equals whatever 12 divided by the tangent of 52 is. which is going to be 9.38 approximately. Now to solve for AC, we have two options. Now that we have two side lengths, we can use the Pythagorean Theorem to solve for AC, or we could set up another trig ratio involving the opposite side and the hypotenuse, which would be sine. We can set up the trig ratio for sine and solve for AC in the exact same way we solved for BC. And I'm going to go ahead and show you how to do it using the Pythagorean Theorem, since we just did an example involving trig ratios. So we know our legs are now 9.38 and 12. So 9.38 squared plus 12 squared is going to equal AC squared. 9.38 squared is 87.9844 plus 12 squared, which is 144, equals AC squared. 87.9844 plus 144 is 231.9844, which equals AC squared. Take the square root of both sides, and AC equals 15.23. Now, if you used a trig ratio to find AC, your decimal is probably going to be a little bit different, but it should still be 15 point something. The reason why they don't match is because we rounded to find BC using the trig ratio, which means the number we plug in using the Pythagorean Theorem is rounded, and it's not going to be the exact same answer as if I were to solve using a trig ratio. Number 3, we're going to use the angle of theta equals 240 degrees to answer 3 different questions. So the first thing we want to do is find the radian measure. So to convert from angles to radians, we take our angle measure and multiply it by pi over 180. So that's going to give us 240 pi over 180. And we always want to leave our answer in terms of pi if we're converting a whole number angle to radian. So 240 divided by 180, we want to simplify to its smallest fraction, which is 4/3. So we're going to end up with 4 pi over 3 as our radian measure. Put radians. B says to find another angle that has the same terminal right. This is also called a coterminal angle. And you can do this based off the degree measure or the radian measure. It's completely up to you. So to find coterminal angles, you add or subtract 360 degrees to your angle measure. Or if you're doing it radians, it's adding or subtracting 2 pi. So if we're doing angle measure of coterminal using a degree measure, if I take 240 and I add 360 to it, one coterminal angle is 600 degrees. If instead I subtract 360 from it, another one is negative 120 degrees. So both of these are coterminal. And coterminal means if I rotate using a circle starting at 240 degrees, either a positive or negative 360, I'm going to end in the exact same place. So now let's go ahead and do the same thing for radian measure. So if I take 4 pi over 3 and add 2 pi to it, we're going to end up with 10 pi over 3. So that's a coterminal angle. If we take 4 pi over 3 and subtract 2 pi from it, we're going to end up with negative 2 pi over 3. So again, both of these, all of these are coterminal angles to our original angle of either 240 degrees, or if you use the radian measure from A, 4 pi over 3 radians. So last one, we want to write the 6 trig functions for the angle theta. So this is where the unit circle is going to come into play. 240 degrees is a point on the unit circle, and if you use your unit circle, you're going to get the coordinate negative 1/2 negative square root 3 over 2. So remember, the x and y coordinate give us sine and cosine. So right off the bat, we know that sine of theta, which is our y value, is negative square root 3 over 2, and cosine of theta is our x value, negative 1/2. Now to find tangent of theta, we do sine divided by cosine, so negative square root 3 over 2 divided by negative 1/2, which we can simplify just to be square root 3, because a negative divided by a negative is positive. Now for our reciprocal functions, cosecant of theta is going to be negative 2 over square root 3. Secant of theta is going to be negative 2. And cotangent of theta is going to be 1 over square root 3. And again, you could rationalize the denominator for cosecant and cotangent if you would like. It's the same way as we did in the first example. So in the next example, we have a sector formed with an angle of 50 degrees and a radius of 6 centimeters, and we want to know the area of the sector and the length of the arc formed. So using our notes, we know the length of the arc is given by the formula r theta, and the area of our sector is 1/2 r squared theta. Now for both of these formulas, it is important that our angle measure theta is in radians, because both of these formulas are based off the fact that our angle is in radians. And right now our angle measure is in degrees. So we have to convert 50 degrees to radian measure first. So 50 times pi over 180, which gives us 50 pi over 180, which simplifies to 5 pi over 18. So this is the theta we're going to use in our formulas. So starting with arc length, our radius is 6 times our angle measure of 5 pi over 18. And when we multiply the 6 to the 5 pi over 18, we only multiply in the numerator, so we get 30 pi over 18, which simplifies to 5 pi over 3, and then our units are centimeters. For the area, we're going to have 1/2 times 6 squared times our theta 5 pi over 18. So 6 squared is 36. 36 divided by 2 is 18. So we're going to have 18 times 5 pi over 18. If I notice, the 18s are going to cancel, so my area is just going to be 5 pi centimeters squared. Number 5, what values of theta with 0 to 2 pi would sine of theta equal negative square root 3 over 2? So first we have to determine what quadrants sine is negative. And if you use your unit circle, sine is negative in quadrants 3 and 4. So in quadrant 3, we want to figure out what point has a y value of negative square root 3 over 2, since sine is always the y coordinate. And that happens at 240 degrees, or if you use radian measures, 4 pi over 3 radians. And then in quadrant 4, we have a y value of negative square root 3 over 2 at 300 degrees, or in radians, 5 pi over 3. So theta either equals 240 or 300, or 4 pi over 3 or 5 pi over 3, depending on if you're doing it in degree or radians. It is important that you know the solution for both. You could be asked to give the answer in degrees or radians on a quiz or test. Last example, given the point 4/9 negative 2 square root 5 over 9 is on the unit circle, find the value of sine, cosine, and tangent. So given it's on the unit circle, we know that the x-coordinate is cosine and the y-coordinate is sine. So right off the bat, we know that sine of theta equals negative 2 square root 5 over 9, and we know cosine of theta equals 4/9. And now we want to find tangent of theta. So tangent of theta is sine divided by cosine, so negative 2 square root 5 over 9 divided by 4/9. which is to become negative 2 square root 5 over 4. And then the negative 2 over 4 can simplify to give us negative square root 5 over